Hello everyone. In this video, we will find the trajectory of projectile motion. Then we will find the expression for time of maximum height, then time of flight, then maximum height and the horizontal range. So let's start. Projectile fired at an angle theta with the horizontal. So as shown in figure, suppose a body is projected with the initial velocity u making an angle theta with the horizontal. So an object is projected at an angle theta with the horizontal with initial velocity u. Now this velocity u has two rectangular components. The horizontal component, which is u cos theta, it is remained constant throughout the motion, but the vertical component u sin theta changes with time under the effect of gravity. This component first decreases when it goes up and then becomes 0 at the maximum height, after which it again increases till the projectile hits the ground. Now under this combined effect of the above two components, the body follows the path OAB. Now equation of trajectory of a projectile. Suppose the body reaches the point pxy after time t. So this is the point pxy and the body reached at this point after time t. So the distance from O is x and y, the vertical distance. So the horizontal distance covered is x by the body in time t will be x is equals to horizontal velocity, that is the u cos theta part, into time t. So that is u cos theta into t. From here we can find the time, that is t is equals to x divided by u cos theta. For vertical motion, that is this part, the initial component of velocity was u sin theta, that is this one. Now at this point P, the gravity is acting downwards but it is going upwards, so the acceleration will be negative g. So the vertical distance covered in time t will be s equals to ut plus half at square from the equation of motion. Now we can put the initial velocity u as u sin theta because the vertical component was u sin theta, and time is x by u cos theta because at this point time will be same. To reach at that point, this time will be same, so we can write x by u cos theta. Now a is minus g, so here it is minus g and half as it is, and t square is replaced by x by u cos theta whole square, that is x square by u square cos square theta. Now if we simplified it, that is it will be x divided by u gets cancelled out, and sin theta divided by cos theta is tan theta, minus gx square by 2 u square cos square theta. Now we have replaced tan theta by p and this whole part as q. So the equation becomes y is equals to px minus qx square, where p and q are constant. And this is a parabolic equation. So thus y is a quadratic function of x, and hence the trajectory is of a projectile is a parabola. Since it's a parabolic equation, that's why the trajectory becomes a parabola. And this path, this whole path is the trajectory of a parabola. Now we will find the time of maximum height. That means to reach at this point the maximum height. So let Tm be the time taken by the projectile to reach the maximum height hm. The maximum height is hm and time taken is Tm. So at the maximum height, the vertical component of velocity is 0. The vertical component of velocity is 0. As b is equals to u plus at, so the b part becomes 0. But the initial velocity was u sin theta, the vertical component. And acceleration is acting downwards, so that is negative g and the Tm. From this we can find Tm is equals to u sin theta divided by g. So this is the time taken to reach the maximum height at A. Now time of flight, that means the total time taken to covered the whole trajectory, whole path. So it is the time taken by the projectile from the instant it is projected till it reaches a point in the horizontal plane of its projection. That means from this point to this point. So the body reaches the point B after time Tf. That is the total time of flight. Therefore, net vertical displacement covered during this time of flight is 0. That means the vertical distance covered during this time is 0 because it reaches from this point to this point. So vertical distance covered is 0. As s equals to ut plus half at square and the vertical distance covered is 0, so s is equals to 0. But vertical component of initial velocity was u sine theta and total time of flight is tf and the acceleration is minus g, so half g tf square. So from this we can find tf is equals to 2u sine theta divided by g. Now tm was u sine theta by g and tf is 2u sine theta by g. So we can obviously say that total time of flight is equals to 2tm. That means 2 times to reach the maximum height. This is expected because the time of ascent is equal to the time of descent for the symmetrical parabolic path. So time of ascent is equals to the time of descent for the symmetric parabolic path. Now maximum height of a projectile. That means this height, hm. It is the maximum height. It is the maximum vertical distance attained by the projectile above the horizontal plane of projection. So it is denoted by hm. At the highest point A, the vertical component of velocity is 0. So we can write v square minus u square is equals to 2as. Now since the velocity at this point is 0, so v is equals to 0. But the initial velocity component was u sine theta along the vertical distance, vertical component. So u sine theta whole square equals to 2, a is minus g and the height is hm. So from this we can find hm is equals to u square sine square theta, this part, divided by 2g. So this is our maximum height of the projectile. Now the horizontal range. That means this distance. It is the horizontal distance traveled by the projectile during its time of flight. So horizontal range can be found using the horizontal velocity into total time of flight. That means total time taken to reach this point and the horizontal velocity. So horizontal velocity was u cos theta and total time of flight is 2u sine theta by g. So if we simplify it, it will be u square u into u square by g into 2 sine theta cos theta. And we know that 2 sine theta cos theta is written as sine 2 theta. So therefore r is equals to u square sine 2 theta divided by g. So that's it. Thanks for watching.